Morning, everyone.
Hello there.
Good morning.
Hello.
Hey, Jeff. Hey.
All right. For the agenda today, we wanted to do a roundup of the specs we have actively in play and come up with a to-do list to finish them off. And then also revisit a couple of topics which we were not able to finish off last time we talked about device identity provisioning. Also, as a heads up, next week we'll have a presentation about OCP lock that is approaching its 1.0 release. And so we'd like to share with the group what's been going on there. All right. I'm going to share my screen. Let's see. The number grows. We now have 4 specs in the new Markdown format that we're currently partying on. The newest one, Attestation System Components, this was a manual effort to port the existing Google Doc into Markdown. So now this is a new source of truth for that spec. It's labeled 1.1, but we haven't actually cut it and submitted it and contributed it finally. Part of that was some dithering on the get CSR stuff, which kind of spun off into device identity provisioning as well here. So we can make reference to both, or yeah, have some references between these docs. So let's go in here. We have the HTML render. Sorry, and I'm also going to post a link to this page in the chat so everyone can see it.
Thanks. I was going to ask.
Yeah. There you go. Okay, so in attestation, HTML render. Some of the formatting did not survive, but that's okay. All right. There's a few notes. Oh, yes. So every open Google Doc comment I preserved in this form, so we can run through these. I'm just going to run through them, and then we can try and resolve them. So Alberto asked, should we remove this reference to Cerberus or the devices that still support it? I am not aware of devices of Cerberus being an ongoing concern, so I'd be okay with that. Is Brian on the call? It is. Brian, what do you think? We'll go back to that. Okay. Note from Brett Henning, we should have a command to discover OSP profile support and presumably a version for the profile. This could be an SPDM vendor-defined.
Sorry, Jeff, I was trying to get off mute.
Oh, no worries.
Yeah, sorry. I just couldn't get to the button fast enough.
No problem. Yeah, so this this requirement says platforms may use SPDM or device capabilities in Project Cerberus. And Alberto asked, should we remove reference to Cerberus or the devices that still support it?
Yeah, there are devices that still support it, but I think they're moving to, they should all be moving to the short cycle of SPDM when we get that get eat.
Okay. Oh yeah, so this should maybe so replace the Cerberus reference with a get eat command.
Yeah, I think that would be epic.
Okay. Let me go. I'm going to note this down. Or let's see. doesn't do it. Okay. Cool.
Thanks, Jeff.
Yeah. Okay, the next one. Okay, we should have a command to discover OCP profile support and presumably a version for the profile. This could be an SPM vendor defined command. We'll have to declare a vendor ID for OCP. We just made that process much simpler. So yeah, we got this. We have the IANA thing. So we know how to make vendor defined commands now for OCP. So that's great. We got a few in the pipeline. So Fabrizio, do you have any thoughts about discovery of profile support, or I guess anyone else in the call? I don't see it Fabrizio actually. So oh no, there you are. There you are.
I'm here. So what do you mean about discovering the profile or the OCP profile? To discover the OCP profile, we have the OID. So what does it mean is that once you get hit, there is the profile OID, which will be registered by OCP, and the verifier will know that it's an OCP profile by parsing that OID.
Okay, so simply by virtue of implementing get eat and doing what the spec said about it, then we're fine.
Yes.
Well,
Then
is this
Okay.
a request on that? Is this a request to future proof it? Like, let's say 2 years time you decide to change get eat or something. Now I don't think we're going to do that, but like usually like a get version command is something that's stable, and then other things, it gives you an out if other things change in the future.
Yeah, and that was kind of my thought was, yeah, it might be handy to have a command to just say, all right, here, which version of the OCP spec does this device conform to?
is that I'm just playing around with this. Is there a way to maybe like decorate the eat with that information? Like, hey, this has the OCP OID, and also this other claim field has a version number. Look at those to figure out how to interpret the rest.
I can figure it out if there is a standard claim for doing so. I'm not sure at this point, but if there doesn't exist, we can make it as a private claim inside the CWT, which is specific for OCP profile. So once the verifier know that it's an OCP profile, will know as a consequence all the claims that are the OCP profile. Among all those claims, you have a version, and through the version, you can figure out if you're version 1, version 2, or version 3, for example.
Which OCP profile? The security one, the data center one?
I think it'd be the attestation profile, so it would be security. Yeah.
There's a couple of different ones you have to.
Yeah, we should be specific.
Yes, okay, we're going to call it OCP attestation profile. We register with an OID, and once you register a profile, that profile is associated with a list of mandatory claims that an attester has to implement. As among those mandatory claims, we can have a version claim, and the version claim can basically redirect the verifier to specific behavior, like if you want to change something from one to the other. I think that might be the best way. If you want to change completely the claim set, however, means you need to register a new OID for the new profile.
And if you want to not do eat, that's a new thing entirely, and no amount of versioning on get eat would help you.
So what you're saying, if you don't want to use a eat, you want to use a different token for attestation?
I'm not saying I do. I'm just hypothesizing. If that's the kind of flexibility we're after, then no, then we wouldn't look to this mechanism. But if we're just saying, hey, we're doing eats, we're doing the OCP profile, we just don't know what claims are required or optional because we don't know the version yet, then I like where we're going with the version claim.
Okay. Yeah. Thank you.
Brett?
Yeah,
Oh,
no,
is-
yeah, I think that could work. Yeah, I kind of had the same question you did, Jeff, that, gee, what if someday we don't do eats, but
I think at that point we just make a new command for whatever we want to do.
yeah,
Yeah,
I think so.
that's the
I think
great part.
yeah, uh, assuming we'll continue with eats for a while, which I can't see why not, then yeah, it would make sense to just make it part of the eat.
And then definitely you don't want to use the get it command to return something else that is not a it. Like that would be very controversial.
And folks on this call who are active in DMTF, I think that the goal is that as we write down the definition of get eat, that it could one day just become part of SPDM 1.x. Is that?
Yes,
2.x.
I think,
Yeah.
I think that's a good possibility.
Okay.
But isn't like this command though, Brett, this is just to see if it supports get eat at all, right?
This one that we're highlighting would do that, but I think we're saying maybe we don't need that amount. We can just say, do it with the get eat command.
Yeah, I guess that would be well, there's a chicken and egg here, right? Because you need some way of knowing, hey, does this even do OCP behavior at all?
Yeah.
Right, so you either blindly send the vendor defined get eat, or you blindly send the vendor defined OCP profile version.
Right.
You
So
may
it's-
not get either one back.
Yeah, so it's more of a layered one, right? So it is a dependent one. You need to know whether it supports the OCP profile, and then within that, what specific requests, because today is get it, tomorrow it may be something else. If we add something, we need to know what specific capabilities within the OCP profile can be supported by the device, right?
I mean, generally, having a get capabilities is a good idea in a ABI. So you know what the capabilities are.
Yeah.
The question is the format of the response or get capability, which need to be standardized anyway, and then you have the problem of the chicken and the egg. Unless you don't say that you want to use a part of get capability from SPDM, that will work.
There is a Brad's working group that's working on defining the claims for device assignment from the device. It's called RATS-D. Is that what you're referring to, Fabrizio? The claims that they're trying to standardize the claims that comes with the EAT.
So the EAT, yes, the EAT is an RFC, has been established an RFC a few months ago. I remember in April or in May or something like that, around that. And EAT is allow, so it is generic. It just provides this entity attestation token, provides some sort of claim set. It doesn't require an implementer to use all those claim sets or also to define new claim sets. So it's very generic, but it allows the implementer to create a profile and be more specific. What we are doing with OCP profile, we are taking that RFC, which you're referring to, we are saying that RFC is expressed as a CWT because that RFC can be expressed as a JSON and as a CBOR. We say that for OCP, for data center, will make sense to express as a CBOR. And we are saying those are the minimum claim set for this profile. So we are narrowing down what was done for the EAT. It is basically the format, and then we are saying what we want to put in that form, in that token for the OCP profile.
But is it still aligned with what EATS-D is defining?
Absolutely, absolutely must be. Like being a profile of the EAT, it has to be.
Okay.
It's similar to what we did to the DP I wrote profile. DP main spec defined a large requirements like at high level, and then with error profile we say, hey, this is what we want to put in the error profile. We want to be a little bit more specific there, and that's why those big spec allow you to define profiles for this reason.
So would it be fair to say that get eat, when a get eat command is sent, that eat would be aligned with what the RATS is defining as claims, or a subset of it?
Yeah, absolutely, that's correct.
Okay.
But I mean, that could evolve, right? I mean, is it possible that there'll be, you know, like additional things you might want in the future and stuff like that? And so
I think they're focused right now on the SPDM, defining the SPDM, but I think they're also looking at other protocols beyond SPDM.
I guess I asked some folks inside of ARM, the confidential compute guys, about, you know, the get eat and just how it aligns with our confidential compute kind of get attestation token. And I mean, one feedback they had was, why is the nonce 32 bytes is a hard-coded number? Because I think they would like to see that being bigger or perhaps flexible. And so I don't know what y'all think about that, but, you know, say in the future we want a bigger nonce, you know, so we're going to do a get eat 2, or are we going to have like some kind of capabilities that tells you, you know, I don't know how big the nonce is or something like that. But
that's a very good feedback, Stuart. I think that we can improve that. We usually put the 32 byte to be kind of like working like, because SPDM is 32 byte for the nonce. But I think we can have two fields. One field is a nonce size, another field variable length of nonce, which provide that. I think this is very feasible to add it. I will leave as a feedback. I will get it as a feedback, and I will work from that. I will improve with that one. This is a good feedback, and it's very easy to announce now.
But I guess
that's a good idea, because we're hitting that right now with the post-quantum stuff, where the protocols that have counts before, you know, their descriptors are able to just change the count to include a bigger value. But the ones that are fixed size are having problems dealing with that.
I mean, I raise it here just because of the question of like, well, if we, you know, will the get eat command itself ever change? Will there be another version of it or flavor of it in the future? And how do we just want to put a number 2 on the API, or, you know, in the future if we change it, or do we want to, like, I don't know, through some kind of capabilities mechanism, just allow the client to know what the capabilities are of the SPDM responder, I guess, is kind of.
We have the command version, so technically we can use the command version, which comes after the command, to specify all these, to give these other constraint. You can say perhaps command version 0 will have this particular constraint, command version 1 will have this other constraint. But for the non-sites, I think that's easy. We can just make from the get-go variable size.
Right.
So what is the rationale for having flexible non-site? It is just for attestation. You send a challenge and you send a assigned response, right? So what we gain by making the nonce flexible?
I have the same question, actually. I don't, not strongly opposed to making it flexible in the API, but I don't know the use case.
Me neither. Yeah. That was Stuart.
I guess I don't know if I can explain, you know, the exact use case, but I did look at our, you know, the kind of the similar command we have for, you know, the ARM CCA kind of attestation, and I think the nonce there is up to 64 bytes, and so and their feedback was, I mean, I can ask more specifics if you guys want to know, but, you know, I think their question was, why is it hard coded at 32 bytes? I guess, yeah, I mean, why is it 32 bytes versus something else?
The question about 32 byte, I believe it goes all back to the SPDM. They already made a choice for 32 bytes, and it's PQC ready, and so I thought like 32 byte was the right balance.
But I think the point last week was that, you know, there was also a view that this you know, maybe used for things that are not SPDM, right?
Yes, absolutely. That's the main goal, to be used not for SPDM is just a transport layer.
So yeah, again, I'm not too sure how the PQC is related to the size of the nonce, because PQC is suppose we're using MLDS. We are just sending a signed response. We put MLDS signature. So how does it matter whether size is 32 or 64?
Yeah, sure. Perhaps you can come back with this.
I can come back with just to get more input on like what the use cases are for the larger nonce.
Because the only reason the nonce is there is to prevent replay attacks, right? So you want to compare it when it comes back to the device. So if an attacker wants to attack the thing, I mean, nonce would not be the target attack, just because, I mean, the verification will fail on the device if the nonce doesn't match. That's the only thing, right? Otherwise, an attacker would not be targeting a nonce for
because
during an attack scenario.
Because the use case here is basically simply that a verifier send a challenge basically with a nonce, and you send a signed response, and that's about it.
The nonce needs to be large enough that you can't brute force it. Like if it was like 16 bits, no good. But yeah, we'll hear that use case.
Yeah, I'll get an answer. For that.
I could also I could imagine maybe it's in like, well, you want to do some extra like binding, like, someone, remote entity provides their nonce, but then something on the machine wants to tack something onto that and hash it in to bind it to the attestation. And now you have to care about the strength of your hash construction and etc. So.
Oh, very valid point. Then 32-bit for SHA-384 will not be enough in that case.
Yeah, still, I didn't mean to kind of derail this discussion into like, the nonce size discussion, but it was just more a question of like, if the command, say that we did want to change the nonce size in the future, and it's not hard coded at 32, say we keep it 32 bytes for now. How do we want to handle that? Just, that or something else. I don't know if there's something else that might come up that we want to add to this command to get eat, but is it through like a versioning mechanism like Fabrizio was talking about, or just a new API of some kind, or what?
Yeah, right now the get it supports as a second parameter the version, so the command version. So I think it could evolve with a newer version if you want to add something else in the future. You can have version 0 having this support as it's defined right now, and version 1 can have a different data structure. So that could be used for that. But yeah, I think the variable size nonce could be from the get-go if we think that is necessary.
So it seems like you've got enough flexibility built into the command to go either way, like to not require a separate versioning command, because you've already got versioning in the command.
Yeah, that was the reason of the versioning. Yes, Brian.
Yeah, I'm generally in favor of fewer commands because, with SPDM, the whole handshake and merry dance out to the device just to talk to it to get some measurements over a narrow I2C bus just takes so long, it's painful. So if you can do a one-shot command that just gets you the attestation claims that you want and move on, that's going to be far more efficient.
Yeah, and that was one of the things, Brian, we added in the EAT profile. We included the certificate chain. So for some use cases, even for SPDM binding, the verifier, the requester, could just issue it the VCA, so basically version capability and algorithm, and just do get it from the get-go after that.
One thing that might be helpful in the base SPDM spec is some kind of, hey, tell me if this version, or if this vendor-defined command is actually supported, because otherwise you're sensing support by testing for error codes.
Yeah, like extensibility on the get capabilities where people can define custom options or something.
Right, like get capabilities will I guess tell you, do I support any official SPDM commands, and that you can enumerate support there. But if to ask, hey, does this device support the OCP defined get eat command? I think the only way to do it is to try and see if it works.
Yeah, similar
I mean,
to
pretty
the
much,
get.
yeah. Yeah.
Yeah.
Which may be okay, but it you know, it's easy. If you want to say, well, it failed because the command wasn't supported versus it failed because the transport fell over or whatever. Like sometimes it's hard to like distinguish error codes because they get collapsed, and it might be nice to say, issue a command which is probably gonna work. We'll return a bool, whether or not I should go on and actually try and call this get command.
Well, like, aren't we going to go implement this get eat and then eventually like make it part of the standard?
You're right. So actually,
like
the use case I just described is not as valuable long term for this command. Yeah.
Yeah, and then just maybe a general thing for SPDM, another thing to consider in there is like extensibility on get capabilities to define some custom attributes that imply capabilities going forward. Like if you can have a field.
Yeah, that'd be interesting, huh?
Yeah. Because it allows to define some vendor-defined capabilities and commands. But I think where this is going is like this getty is super helpful in the short term. At least for CSPs, we can just we obviously pre-qualify all devices, and I know not everybody can go pre-qualify devices. So in test, we can determine whether they support the needed commands and block their path to production or path to the system if they don't have the necessary commands. But I think that's not going to be possible for everybody, especially maybe smaller outfits. So they definitely make use of a get capabilities as a discovery mechanism.
Mm. All right, cool. So I think I filed a couple of issues based on this discussion. So I think I'm just going to delete this note. Let's see. All right, capabilities for SPDM. Well, sorry, was there any other discussion on this topic before we move on? I think this is a really good discussion. Thank you all for the feedback. Okay, cool. SPDM note: we need to add capabilities required to support 1.1.2 commands listed: key, XCAP, CSR cap, chunk cap. Okay. Now, key exchange. So for SPDM, like these required commands, we decided in discussion, we're not going to list off the key exchange stuff because we don't just want key exchange for the sake of key exchange. We want it because it does TDISP. And so defining or having OCP say, hey, also do key exchange is not, I think, the correct layer. We just need to say for devices that need it, we will ask for TDISP. And not all devices need TDISP. And so for those devices, we won't say anything about key exchange. I'm assuming that stance is still okay with folks. Assuming it is, we don't need key exchange cap here in this list, but CSR and chunk we would need. Yeah, we have chunk send in, so we want chunking, which means we'll want the capability for it here. So, okay, that means also, I don't think we need these backslashes. cap, and I will do CSR cap pending discussion of the next bit. Oh, shoot. What did I do? No. Oh, right. I don't have my handy table formatter extension here. Great.
Jeff, if we go down this get eat path, do we need get measurements?
Well, okay. Probably not. Probably not. You're right. Fabrizio, I forget the definition of command. Can I ask for the E to be unsigned?
Not right now, because the ETAS is being defined as CWT. The CWT is signed. So technically can for it, but it cannot for CWT. So it's kind of a limbo. So we can do it, but we risk to be out of spec.
I see. Okay. What I'm thinking about is, sorry?
No, actually, I was just asking, but I don't participate regularly. So this E token has to be signed by the DICE LES certificate, right?
Yes.
I mean, you could create a version of the command that instead of calling it get eat, just call it, I don't know, get attestation token or something, and then have a version of it that returns an unsigned, a data structure, and one that returns signed is with a parameter or something, I guess, maybe. I don't know if that's useful, but if it's really useful to get the unsigned version for some reason, maybe, the command could do that as well.
Yeah.
Or perhaps to make it compliant with the CWT specification, we can, I think that just returning an unsigned it is fine, and just being like perhaps pedantic on the CWT spec. But what if you just signed with an ephemeral key, use an ephemeral key and sign it? Are you think about the derivation of the ephemeral key is going to be still time consuming, and you want something to be returned fast because you have a secure session, Jeff?
No, well, here's what I'm getting at is, so let's say you're in a secure session, like in a TDISP context, and I think I mentioned this before, it would be really unsafe to get the EAT that is, has a self-contained signature and pass that on to some verifier without telling that verifier, oh, and here's who I established the session with. Like, it'd be easy to make that mistake because you have two signatures and it's not obvious that, no, in a secure session context, a signature as part of the EAT almost doesn't matter at all.
What, would you not just ignore it?
You could, right? If you're doing the right thing, you just ignore it. Yes, and then at that point, it's just then the problem that the signature poses is it's a foot gun, and you ignore it, and that's okay. But it's just extra bytes you had to pull across you didn't need to, which could be expensive in a PQC world.
I think would be, yeah, no doubt about it. Yeah.
So I think now, and the reason I bring this up is because you're talking about can you just ditch measurements for EATs? Well, one thing that measurements can get you is that you can ask for them signed or unsigned. Like if you're in a secure session context, just get them unsigned and they inherit the security of the session.
This would be for the situation where the verifier has secure session with the device, right?
Or a delegate of the verifier, yeah. Like imagine there's a customer confidential VM talking to an accelerator and the customer's verifier is somewhere in their own cloud and say, hey, VM of mine, which I already trust, what devices are you talking to and what are the measurements? That kind of context.
Yeah, the only advantage I see that if you sign it, then it ties it to a specific silicon, right? If you say a DICE LES key, then it is basically tied to a specific silicon. Where
You'd get that binding anyways, because when you set up your secure session, the transcript is authenticated using the dice keys.
okay,
So just make sure you're getting the eat over that session.
okay, got it. Thank you.
How do you expand that session to the remote verifier? I think that's a separate session, right? Unless you are using SPDM over
The way I
TCP/IP
imagine,
binding.
yeah, the way I imagine it would work is that, so assume you have a trusted session to your, like a trusted MTLS or some kind of TLS session to your VM that's authenticated using the VM's confidential compute keys.
Right.
Then you could just have that VM terminate SPDM and report back to the verifier, here's the dice identity that I talked to, and here's the measurements that I got. I don't see a need to have the
Right, but if it's not signed, how do you bind that with the dice identity?
Well, the transcript hash would be signed by the dice identity, and so the VM can get more data over that channel and know that any data coming over that channel came from that device that signed the transcript when it did its key exchange.
And so you're basically putting implicit trust between the verifier and the VM.
Yes, which you can make explicit by, anchoring the TLS session to some key that the VM attests to.
I guess it's going to be kind of indirect binding, but it could work.
You're right. It would be indirect. Let's say I trust the VM, and therefore I trust what the VM tells me.
Exactly.
Yeah. Which you got to kind of do anyways if you're spinning up a VM.
I think the remote verifier will need to get both certificate chain anyway. We'll get to verify the certificate chain that user to establish the secure session anyway, and perhaps could be a new policy for the so perhaps when you're sending your signed it, you're also sending the other certificate chain that will be used for establish the secure session, and it will be goal of the verifier, making sure they both come from the same device.
Yeah, which can be a little bit non-trivial because maybe they use different dice leaf keys, and now the verifier needs to be smart about walking them back and understanding, oh, okay, the IDEV IDs are the same. FMCs are different. That's weird. I don't know how to deal with that, It's
so because what I'm thinking, even if it's not signed, perhaps like the integrity protection through the thing could be, even if it's a secure session, it could be compromised not even maliciously, and then the verifier will not accept by default a token that is not signed, even if it's over a secure session, because he want to be sure, because the remote verifier cannot know what comes all the path from the device to the remote verifier. So he cannot assume there was a secure session between the guest VM and whatever device he got would have got the hit. So by putting something unsigned, I don't know if the verifier as a default appraisal policy will disregard the token anyway because it's unsigned. So I think that I agree with your point, Jeff. We had a discussion in the past, but I think there will be will have more sense to have like a verifier, to write this as a note, that the verifier role is to make sure that it and the secure session have the same provenance, which is the device identity.
I think we are talking option here, right, Jeff? It's not like we want to go one way or the other, right? You asking if we can do both, signed and unsigned?
Yeah, I was asking if I can if I can save the bytes and get it unsigned, and then pointing out there's efficiency wins there. If we want to write like a guidance paper to say actually you should get both signatures and compare them like this, I guess I remain a little bit skeptical that it'll be as simple as that, but we can certainly run it down. Yeah, I see some benefits. Not anyways. We can that's discussing.
Yeah, or there can be some way to cryptographically bind this token to the session. I don't know if something like that. Just
Yeah. Okay. Cool. So let's revisit this comment. Do we get everything? Got chunk, got CSR, ignoring this one. The measurements, I'm going to change this to a note from. All right, and we will tag that. I just want to see if there's any more comments to get.
Would the eat ever need to be broken up into chunks?
Probably. So you have your chunk cap here.
So that okay. So that would like SPDM would already handle that if it was multiple chunks.
Yeah.
Okay.
That's how I imagine it would work. Now Mez fresh cap, we listed that here, and that is a problematic has a problematic definition in SPDM. As written, let's look at 1.3. The responder shall support recomputing all measurements without requiring a request and shall always return fresh measurements as part of measurements response. So recompute all measurements. You're not allowed to cache any of them, like including boot firmware measurements. And this is acknowledged. We've discussed this before in this group, and I'm not sure what the latest versions of SPDM have done with this capability, if they've changed it, the wording. Is there a 4?
1.4 is out.
Okay. Still says recomputing all measurements. Okay. So I think we say, I don't think we should mandate this behavior. I don't think we want it.
It's even stronger than that. It seems highly undesirable.
Right.
Yeah.
Like verging on broken.
Yeah. It's not a good idea.
All right. So we're going to nuke that one. Coolsies. All right. Go back to the rendered view.
Wouldn't it be possibly desirable to not only mandate that it not return fresh measurements, but it never return fresh measurements?
To say actually require the inverse.
Exactly. At least it's worth discussing.
Let me look back at what the 0 means. Okay. As part of measurements response method, the responder may return measurements that were computed during the last responder's reset, which is what we want. So looks good to me. What do folks think? All right, I hear no objections. Cool. Thank you. All right. All right, then we get into SPDM get CSR stuff. I think what would be nice to do here is say delete all this stuff and just reference to device identity provisioning spec, which itself talks about null sign CSRs and the other vendor defined commands and flows we need to get what we actually want out of this.
I agree.
Yeah, that sounds like a good idea.
Okay. So that means delete that. I'm a bit OCD here. Okay. All right. Don't need that. Okay. So what's the URL? Sweet. Back to rendered. Okay, recommended algorithms for SPDM. Note, I would prefer to see the requirements interoperability move to the verifier. It generally has lower security requirements than root of trust and a more performance for computer environment. For example, a tester must support ECDSA, SHA, GCM, MLDSA. A verifier may support other algorithms. Okay. What is, sorry, tester are allowed a large number of algorithm combinations. To improve quality, the test devices should follow the guidance in the sections. Require support for the following algorithms. I like the idea of making this list smaller and not having to support all these flavors of RSA.
Yeah.
And EDSA, etc. That's a big list of SHA-3, both 120 and 256, Cha-Cha Poly. Yeah, I think this maybe is a bit big.
So what is the request asking for? Verifier having different algorithm sets? He's saying like if the verifier has more algorithms, it's not asking for deleting any of the algorithms.
Yeah, I think okay, if I'm trying to put on Jeremy's hat here, he's seeing perhaps we're asking the devices to support all these algorithms to cater to every possible kind of verifier that might want this one or that one or that one or that one.
Maybe in other words, he's asking for adding more algorithms rather than deleting algorithms, right? He's saying let's support any possible algorithm that can be implemented on the verifier.
Yeah. Maybe
I understand it as limiting the number of algorithms on the device and put those requirements on verify to support those specific ones.
Yeah.
Like as written, this is not a list of things the device might support. This is things they all have to support, every single one of them.
Yeah, exactly.
I think that's a high requirement.
Yeah.
On this.
But I
Perhaps
agree
it
with
should
your
be
comment, Jeff, about like deleting some of those because of post-quantum risks, like the 2048, for example, for RSA.
Yeah.
I don't have a comment on the exact algorithms that we list here, but shouldn't it be perhaps at least one of, like say, the device must support at least one algorithm from this list of asymmetric and of hashes and of AAD, requiring at least one of on the device would be a basis for guaranteeing compatibility without foisting onerous requirements onto every single device implementation.
But that requires the host to support all of them then, because it never knows which devices it's going to encounter.
Sure, but host software in our experience at least is much more malleable, easier to support, and frankly easier to deal with bugs in.
Okay.
Yeah, I agree with that, right? Why put the requirement of every single small device, right? To have all of them.
In general, I've seen, especially if you look like at TLS, there's a mandatory set of algorithms that you have to implement, and that will hopefully lead you to interoperability. And then you can maybe encourage, you should have some of these, and then anything beyond that is, whatever you like. But if interoperability is one of the things you're focused on, you gotta make sure that everybody has those. But a list like this that's tall order.
Yeah, I agree.
Jeff, I think one way this spec may be interpreted the way it's written right now is that a tester must support all of the algorithms listed in this table here. And the way I interpret Jeremy's comment is instead of enforcing a tester to support large number of algos, how about letting the verifier support them so that if a tester has limited algos supported, verifier can handle that. And the spec probably could be clarified to state that one or a few algos from this list should be supported rather than stating that this is the algos to be supported without giving guidance whether all or any should be supported.
Yeah, and I think this list has to be revised anyway with PQC, right? So maybe we can add some wording that the device shall support at least one classic algorithm for signing, one PQC for signing, one for key exchange, classic and PQC.
I agree.
Just go and pick one. Go even further. Why not just pick one?
Have us pick one?
Yeah,
Yeah, it's that. I'd like to see that.
The only thing that for some implementations, they are still battling between SHA-2 and SHA-3, so it may be hard to choose. Some folks have not implemented SHA-3 yet.
Yeah, and they shouldn't, right? They should stick with SHA-2 according to CNS, right? Yeah, unless it's in the unless it's part of the algorithm.
I would also say that picking a specific algorithm would then limit compatibility on devices where they want to use hardware offloads for performance reasons.
By the way, I have a question. Has NIST defined a set of algorithms that are officially deprecated, like RSA 2048, or is it just still, research papers and stuff?
I don't know, but I'm sorry. The question before that was about performance.
I didn't follow it.
No, I didn't have a question. I was making a note that if we reduce the list to if we pick a winner from each of these categories and mandate you must use this, you must use this, you must use this, then it will be difficult to implement the OCP profile on devices that are reliant on hardware accelerators for computation of, for example, hashing.
How do you make that out though, right? So if you pick, you must have this, you must have this. It doesn't mean you can't have the kitchen sink.
Yeah.
What it's saying is a minimum. Instead of saying minimum, you need these 20 things. Say minimum, you need this exact thing. And then if you want to do the kitchen sink for all the offload purposes, by all means, go at it and add the kitchen sink.
Right. And just piggybacking what Brian said is if you lock in a mandatory for each one of these categories, you could also go a step further and strongly recommend, additional ones and then allow anything. But, and I've seen that use of recommended is a way to sort of foreshadow changes that are anticipated. It's like before all the PQC stuff was sort of beginning to get nailed down, we were already starting to see recommendations in the TLS space that says, oh, you might want to be able to do some of this. So there's some advantages to having, a minimum set, some that are encouraged, and then free for all with the rest.
So I was just wondering, can we just specify the minimum security strength we need? For example, if we PQC, we can say the minimum security strength is NIST PQC security level 5 or 3, whatever.
Yeah, well, then you get into an argument as, are you tracking NIST, which is currently at 112, going to 128 in 2030, or something else, and that then you can get into the arguments. Not that I've said in some of these in the ISO space as, from the PQC, what is their actual security strength? There's some back and forth on it. So it doesn't necessarily buy you anything.
I apologize.
Do you still need this full table to say, well, the verifier must support the full list, or are we just going to be silent on what the verifier's responsibilities are?
I think this spec is not meant to be normative on the verifiers. So
by specifying the mandatory and maybe the recommended, that gives you a sort of a target for the verifier as well. So the verifier might do the recommended as well as the mandatory, but in reality, if you've got mandatories, that's all you need to basically lock in.
And I apologize to the person who asked about has NIST officially said anything about deprecated algorithms. Does anyone know?
I don't believe they've updated. That there was an executive order that came out of the White House that sort of changed the game a little bit around TLS and some of that, but I'm not aware that NIST has fully responded yet.
Yeah, I do think the same.
And also, I think that there will is a specific requirement for data centers, right, where we need more security. So we can specify from our side also that there's a minimum security we need to be a data center, basically.
Okay, great. So we have, I put MLDSA and MLChem up there, so just that note.
You want to also add the LMS? I mean, there's another signature scheme or something for.
I think
I
this
know
is for
that's
attestation. I don't think LMS will be used for attestation. Can be used for attestation because it's stateful.
Yeah. That's why the easiest thing is to just specify the next level security level. That will be easier instead of specify the particular algorithms. The PQ list keeps on changing also, right? PQC list is also maybe more cryptos will be added to PQC list.
I mean, even if it's stateful, it could still be used, but it's okay. I mean, I was just wondering.
Okay. Just gonna quickly skim. Have any other notes? No. Okay, sweet. We hit all the open comments of the previous Google Docs. That's great. Haven't yet finished addressing all of them, but we've touched them all, so that's great. And we're right on time. So thank you all for this feedback and work. We will, so next week we have that OCP lock discussion, and then we can take these up again. And I know we didn't actually, we had meant to discuss, to kind of have an overview of like what needs to happen. I think, by the way, like the priority should probably be on the attestation and device identity provisioning specs to get those out the door, because this has been sitting there for a while. And I know there's teams that actually want to go implement this stuff pretty soon. So
yeah, and I feel like it's in good shape too with the identity provisioning and attestation stuff. So if we want to go with those, it makes it's good ordering.
Can we include the EAT profile as well as part of that decision? So since we put get EAT as one recommended command.
Sure.
Yeah.
I'm just not as aware of like pressure to implement that command, but yes, we can bring that in.
Awesome. Thanks a lot, Jeff. Yeah.
Jeff,
Great.
if you in this new spec location, how would you like us to provide comments outside of a meeting context? GitHub issues, pull requests?
GitHub issues would be great. Pull requests are welcome either way. Yeah.
Thank you.
Thank you. All right. Have a good week, everyone.
Thank you.
Thank you.
Appreciate it. Thank you.
Thank you.
Yeah. Just a comment. So ops basically has set requirements for basically all of our manufacturers, CM, Fab, and ATE. And we basically pulled their audit results, and ATE turned out to be one of the like worst performing in their overall like sort of security posture. And the story was essentially we've worked with them for so long, everything is grandfathered, but when we go to a new CM, we give them all these requirements and they just build it. And so when we looked at that, I think we had, you know, not a large amount of concern, like basically installing at the DLT sites. I think we are going to like threat model the particular flow when it finalizes and see if there's any particular things we want to add or mitigations we want to put in place. But like at a first level, there wasn't like a from like an ops security, cybersecurity regulation audit perspective, a big difference between the AT and CM sites. Yeah, that's factory programming. Yeah, no, I think that's my impression. I knew him a little bit when he was at Intel, so this is 10 years ago, I think, when he was in that TA role. Yeah, he was very like sort of high level execution oriented. So like not opening the code, but like going and driving a feature, talking to the executives, getting people aligned if there are resources needed, getting that lined up. I think yeah, and that's kind of my impression of like a TA role. Like you're basically supporting an executive, but basically running technical stuff to get all the yeses said, the stuff lined up, make sure the right stuff happens. And in my interview, he had that kind of mindset. Like when we were talking technical things, he was, very quick about describing various features. So yeah. I think I would say if it's a very cross-functional role, it's a very good skill set. So if he's got to go to ops, if he's got to go to the hardware, the SOC team, if he's got to go to the system team, if he's got to go to marketing, if he's got to go to like the RMA people, and negotiate amongst them, like drive them all to solution, get resources. Like I think that's kind of like the skill set naturally lends itself to that kind of cross-functional work. Ryan, is that your? Yeah, sure. So behaviorally, he was really good. He was able to like dive in deep on the topics that I'd asked about. I asked him, so like I basically gave him the like, hey, so like kind of like a Kobayashi Maru of like, hey, so you have 10 million parts, they're sitting at Foxconn. Do you like put Intel's red unlock there? And he like paused and thought about it for a while. So like he was very fast at like quick answers, and then like when there was like an unsolvable problem, he stopped, and then he was like very tenacious at trying to solve it, and I had to kind of like shoo him away. So I thought that was like very good behaviorally. Um, uh, Looking through his resume, he did like there were things I kind of know who worked on, and I didn't know that he was aware of them. But I think he worked on maybe some of the productization and like customer facing aspect of it than like the raw microcode aspect of it. So I did notice there were some things that like he had claimed he had worked on, which I think he probably had worked on like the customer facing side, but maybe like not from the very beginning, like architectural concept. I agree with what Ryan said. He had a very like chip and firmware kind of focus to what he was working about. And my understanding was like this was maybe like manufacturing security or like supply chain. And so I didn't get a great sense that like he knows a whole lot about Foxconn or ATE facilities or like how to run the craziness that ops runs or how to kind of interact with that. And so um so like that was maybe one of the drawbacks that like if you're hiring at a super high level, like and I think he's like a very good candidate, but like he's like if you're looking for a very specific skill set, he doesn't have, at least in my what I saw, I didn't see like super great exposure to like manufacturing / operations, which is understandable coming from Intel. Like they make chips and they barely make boards. It's not their bread and butter. Maybe Ryan would disagree because they do make some boards, but like that's not what drives their business. And so like I kind of got the sense that yeah, like like as just like if you said general like engineer, yes, great. If you said like his role is to go and drive a bunch of things into ops and manufacturing, I kind of say, okay, he's not better than the average engineer in terms of his like background or technical exposure to that environment. I think the other thing I'd say is I kind of try to like he was very quick to answer a lot of questions, and so I think twice I kind of asked like, hey, how would you threat model this? Kind of trying to poke him to like step back, think of like the 15 things that could go wrong, enumerate categories, like where would you start drawing through? And most of the answers kind of dove deep on one topic, and then we had to kind of pull back. And so I think in the Slack channel, I kind of just, hey, if anyone else can ask him about threat modeling, that would be good. Because he seemed to be like very like one solution oriented, and I didn't get that sense. But again, it was a very brief interview, but I could get that sense of like he could threat model the whole thing or had a lot of experience doing that kind of in a formal way. But behaviorally very great, and I second that, like it would be an excellent like feature driver or execution person for getting something done cross-functionally. So I think key management can mean a couple different things. And so in terms of like provisioning keys in the factory with HSMs, I don't think that's necessarily necessary, but I don't think that's what he meant. So he worked on the system that basically like pushed keys into an SGX enclave for software. And so basically you could take some software that uses OpenSSL, you drive this feature, and now all of a sudden like your keys are protected by SGX, but you still have OpenSSL. So it seemed like very much a operational software key management, not necessarily a manufacturing lifecycle key management. Yeah. Chris, I mentioned this briefly, like behaviorally, the TA thing and his upward orientation, I think makes him very title focused. And so if you were deciding like, would I raise the comp or would I raise the band? I think he would respond to the band more than the comp. Hey, Patrick. Sorry I'm late. Yeah. Okay. I think I'm probably the right person. It kind of comes there's a bunch of people, right? So uh the secure provisioning flow was defined before I got here. And so I think I'm responsible for it, but I think Sitaram might have had more of a hand in the architecture of it. And so some of the choices he made were not the choices I would have made, but they're still pretty good choices. Yeah. Yeah, so there's an FD 293, I think. So maybe if you 293 might be too generic of a number to search your email. Let's see. And so that was the feature description. There was some Confluence discussion of it, and there was a lot of like technical work. A part of it involves basically booting this what we call in manufacturing FMC, which is essentially firmware to run on the FSP, which is our version of the PSC on the GPU side. It's like a different key. It's signed with a different key, and it only works in this factory flow when you've opted into this. Yeah. Me. Yep. Mhm. Yeah. So I can send you. We do the like a spec. And we haven't kept them all up to date. I should probably go back and up to them. I think for Blackwell we have a good example, which is basically it's kind of a spreadsheet. It describes kind of like the hierarchies. Sometimes you have to know a little bit about the product because a lot of the products have like two roots of trust, and so like you might see in some of these in some of these hierarchies, like there's actually like two leaves, like one like in the GPU case, there's a leaf for the GSP and a leaf for the FSP. And so I think what we did was I have to remember if we did one L2 for Blackwell generally. So usually we do like an L2. Sorry, do you know what I mean by L1, L2, L3? I should start with that's the jargon we use. So we talk about like yeah. So L1, yeah. So L1 is our root. It never changes. Funny bit of trivia. For some weird reason, we actually created two certificates for the same root key, and so sometimes people complain that like the certificate doesn't match because they hashed the certificate, and we actually signed a certificate for the same key with two different dates. So our L1 is a little bit weird, but we have an L1. L2 is basically kind of like product family. So for L2, like Blackwell would be a family, Rubin would be a family, Vera would be a family, T25X would be a family. And so typically we'll make an L2 for each family. Below that, essentially we create like the L3, which are the ones that we actually issue the CSRs with or issue the certificates with. In most cases, sometimes they add extra, but basically, typically the CSRs are created like at a product specific level. So under Blackwell, we might have GB100, GB20X. Yes, and so there's an interesting nuance there too. We have what we call the legacy flow and the secure provisioning flow. And in the legacy flow, essentially in San Jose, in our old model in San Jose, we have an HSM and we have an L3, and the HSM picks a key and it creates an L3 for it, and it encrypts this whole thing and it sends it to the tester. And so in our legacy flow, the HSM in the factory isn't really doing much. It's just kind of like caching data and passing it to the tester and putting it in. And in the secure provisioning flow, we kind of forward deploy those L3 certificates into the factory. And so they're in HSMs in the factory at that point. And so there's a different model in where that L3 sits, whether you're using the legacy flow or kind of the modern flow. Yeah, and then just one more comment is that so typically what that means is that for the legacy flow we have kind of like one global L3 because we serve it out of a central place and it goes everywhere. But for those factory ones, we end up with like 16 or 32, or at least we have plans to blow it out to be a number of L3s because we have different factory locations. The DDAs might spare over. And then the other thing that project kind of pushed us to do was to support rotation of L3s. So kind of the idea that like every year we're going to set up a new L3. And if someone comes to us and say, oh, by the way, the NSA like owned that factory from like 2025 to 2026, we'll go, oh, okay, that was the year we were using this particular certificate. So like we could revoke that L3 for that factory location. We might deploy the same L3 into them. It depends. Essentially they're set up as hot swaps. So there's two of them like in a pair. And so I don't know if we have the infrastructure to within the hot swap pair support different ones, because like the protocol I think assumes that like there's certain places where you write like an index number and like the yeah. Yeah. Yeah, I think generally they have this model where like we have what they call it. So the HSMs in the factory are called the DDA, and the centralized HSM back in the in San Jose or wherever is called a DKG. And so kind of the model is that like the trust flows from the DKG to the DDAs. And I'd have to double check for the like the L3s might even be generated from the DKG and then pushed to the DDA through like an HSM not quorum like you know like HSMs can like join a group like they're essentially I think the keys might be chosen on the DKG but pushed to the factory DDA HSMs through some kind of a like key export as part of being in the same. I think in Cypher called it security world. I don't know what the jargon is for the HSMs that ISS uses, but basically like in when ISS makes those DDAs, they join them to like the same like cryptographic group or HSM group. Yes, they make their hardware, they help deploy it. They basically give us like an operational interface to manage it. I think the DKG we might physically possess. Yep, I am. Yep. Not on me though, not on me. Yeah, so so by our contract, they will have support by middle of next year. Engineer to engineer, they've told us like I think they have it now. However, it's very non-performant, and I'm not sure what the security is. So essentially, they've played with it. They have it in their lab. If we said make us one sample, they could make us one sample. But like they are not at like okay, you know, we'd like you know to do 10 million a month, you know, starting now. They're not at that like volume production stage of it. And yeah. And so like our total contract, we actually just re-signed it with them, is something like 120 million chips, then 130 million chips, then 150 million chips. over the course of the next 3 years. So like it kind of goes up over that time frame. And so like we typically do like, you know, I think this year we almost hit 100 million provisions. That being like the full chip, and inside the chip blob you might have PSE, you might have Calyptra, you might have FSP, you might have like the molecule KTU pairing. So there's a bunch of stuff that gets wrapped in that, but like I think we've done, you know, near 100 million devices. Mhm. Yeah, and when we say the DDA, the DDA is essentially like I think a 1U server with an HSM inside, and so ISS sells us this whole box, and they basically like, yeah, so they make some like super stripped down version of Linux that runs on that DDA. And I can talk a little bit about that as well. So there are two things that those kind of APIs they provide. They have what's called general blueprints, and so they have a list of like 40 things they do, you know, from, you know, generate a random number to like sign this certificate to, you know, a whole bunch of different cryptographic operations you could expect. Yeah, wrap a key. Yeah. So there's a bunch of things that are like standard blueprints which they can just install, and that's kind of how our NBU team, so the Israel networking team, they also ended up using this provider, and we kind of chat, but like they're kind of managed by their team and we're kind of managed by our team. But they essentially basically use these blueprints typically at like contract manufacturers like Foxconn. So typically they'll take the same DDA hardware, they'll use these generic blueprints, and they'll set up like certificate issuance for like a TLS certificate for an Ethernet switch or you know, their stuff. For us, we typically do custom blueprints. So essentially, we'll go to them and say, "Hi, we'd like to talk to you about Skate Generation 11." So Vera is Generation 11. In Generation 11, we will have one PSC, meaning it has these, you know, these 5 keys, this one identity key, this one certificate. It has Calyptra. Calyptra has like this KDD value. It has the UDS seed. It has the certificate. Yeah. So exactly. So we essentially define this like this blob, which is everything that's needed, or so we've split it apart, but generally it's everything you need to provision a chip. Things we split up. Yeah, from like a security architecture perspective, it's me. I work with the chip leads to understand like what's actually in the blob. And then there's also a very important part that I haven't mentioned yet, which is the Skate ATE team. So I kind of do the like, here's what the spec is, here's how it goes. We work with a team in ATE. Venuta Shetty is the lead for actually running it. So they write test code, they hit the HSM in the factory, they pull the data out of the HSM and actually write it in fuses. And so we rely on them a good bit. They work closely with the ISS as well for the actual, what does the blob look like? Like, how do we get the format right? We're all working on how we get the format right, but like how we program it. And they also kind of manage the DDAs sort of operationally. So like I mentioned that they cache blobs. So, you know, in the legacy flow, we cache blobs. They kind of set the number, like how big the cache should be in the factory. So they might go, oh, this factory is going to make a whole bunch of GV100. So increase the cache of GV100 blobs at this factory to 100,000 blobs. So there's 100,000 like unissued blobs sitting on the factory at the DDA at any one time. So if the network goes down, they can keep making up to 100,000 Blackwells. So she kind of looks at the queues, like she manages like flushing the queues. Like sometimes we'll do like dev, so like we'll set up like dummy certificates and we'll test it out with like a certificate that's rooted to like NVDev instead of rooted to NVIDIA. And so she'll like manage that and setting up the profiles. There's also a thing called profiles, which essentially like for like let's say we'll do like a generation, which might be Blackwell, or a generation that's Vera, but underneath that we might make 7 different kinds of products where like one is 102, one is 100, one is 110, and we would have slightly different properties. Like maybe we would change some keys, maybe we would change some strings in the certificate, so it says GB 102 or GB 100. And so like those minor tweaks are done through something we call a profile in the ISS interface. And so we define this like a generation is like it's Blackwell, and then we can set different profiles for the minor changes, like just rotating a key, but basically doing all the same crypto and all the same number of keys, the same crypto, just like different strings or different key values. Mm-hmm. Yeah. 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 So we're gonna start one up for GR 150, actually for GR 100 for Ruben. So we had one going for Blackwell. It kind of lost steam because on Blackwell we locked down, like we only had one key for production, for this production manufacturing FMC, and we couldn't change the firmware. And so we were kind of doing this complicated thing of like booting firmware on a tester and fusing, but we could only do it after like security reviews, and it took us like a month to get like the firmware signed. So we were basically debugging this flow for the first time, but not able to rapidly iterate on the firmware. And so basically we couldn't debug it. So we change the architecture, like minor tweak in Ruben, where we have, I think, multiple keys, so we can create a debug key and a prod key. So we should be in a position to enable debugging it. So we intend to try and set this up for Ruben. So we have Ruben, we have GR150, which is a follow-on to Ruben. We'll have Feynman. These are all places where we want to turn this on. And we'll have a chance to. We also we have an intern coming. Actually, my next meeting in half an hour is to talk internally about like what we're going to set the intern up to do. And I think what we're going to try and have them do is drive the process of getting this flow kind of debugged and up and running. Yeah. But yeah. Yeah. So yeah, we call it like manufacturing FMC. So it's sometimes called MFG FMC. So historically, Akanksha Parawal was the pick for it. So for Blackwell, she was the pick that was driving it. I will Slack you, or I'll type in the chat a name. My best attempt at spelling. Okay, that was my guess. Actually, I probably should have done the add. Let's see if I add it, I can. No, it's not coming up. Okay. Anyway, but so Akanksha was the pick. Yeah. So she was the pick. I think she's a manager now, or she might have even been becoming a manager then. And so going forward, she might delegate this to someone on her team. And I think there might be a mail somewhere in my email. There's a mail, I think, of her saying, "Oh, I think it's this person that reports to me. They'll be covering it for Ruben." But offhand, I don't recall the name of the pick. So I'd have to dig that out. But she has the like the technical experience of doing it on Blackwell. And so we'll probably pull her in anyway. But yeah, so she's the one who was responsible for the manufacturing FMC. I think there was a similar code for programming. There's a ROM patch. So there's like a patch infuse kind of mechanism for some of the ROM. And I think the manufacturing FMC code was like leveraged or shared between code run for this ROM patch and for the secure provisioning. So and I think ROM patch did become POR, so I think we got that in, but I think secure provisioning didn't finish for Blackwell. Yeah. Mhm. Okay. Yep. Okay. Okay. Yeah. No worries. We'll set it up. I suspect it will be in the evening. The last time it was in the evening because Akanksha was based in India and Daisy was in China. Okay. Oh, okay. Okay, that'll work. Yep. It'll be towards the very end, I think, because there's like I think folks in Shanghai and folks in India, and so it'll be okay. Okay. Cool. All right. Yeah, no worries. Thank you. Good questions. Yep. Talk to you later. Yep, bye. Hey, Moen, how's it going? Oh, nice. Okay, and I think there were two topics we talked about, and if we roll to the title, I think I actually noticed something there that described maybe something different, so that we should think on. So, um, doing this at board level was something that we were looking at in particular with co-op, and there was also like a more basic line item of essentially bringing this up on GR100. Um, and I think we were on the more basic, like, let's do the bring up on Jira 100, more than the let's go and do the extra work on enabling it for co-op for 150. Seetherm, is that your recollection, or okay? Yeah. So I was like at board level in the title, like suggests it's the more GR 150 thing rather than the baseline. Um, yeah. Yep. Mhm. Yeah. And I mean, Seetherm. Yeah. I, yeah. I see. Yeah. Because I was gonna say that, like, even the secure fusing prototype, like getting that up like in the course of an internship, up and running and tested and all debugged, in my mind seems like a good amount of work, or maybe even slightly aggressive for like the time we have. And so like I wouldn't want to set the expectation that we expect him to succeed with both um, the secure fusing and like constructing the database and getting that all going. Um, but I think that's a good point Cedar mentioned, that like if we have multiple paths for him to progress, he has the ability to swap if he gets blocked on one, right? And it is possible that there's a lot of dependencies on this that they may get blocked by, and so yeah, it's good to have. Okay. So that I think that's a good question on scope. I think there's like working cross-functionally with teams, and I'm not sure what part that they would really be hands-on and what part they would be kind of like tracking and driving and debugging. I think like at some point there's going to be like chip on tester, and we're running manufacturing FMC on the chip on the tester, and we're debugging it. And so I would imagine that like they would work closely with Akanksha Parallels team and whoever owns manufacturing FMC. I'm not sure, does Akanksha, did she pass it off, Seetharam, to someone on our team? To who? Tarun? Okay, Tarun. Yeah, okay, that's easy. So okay. So they work with Tarun on what the baseline firmware does. Basically, I guess we would kind of try and shepherd security approvals. One of the big problems we had with Blackwell was that we couldn't separate like debug and prod software, and so it was very difficult to get approvals. And so there might be, hopefully we can just like bypass this by saying we have a debug key and we just get it signed. But I think essentially it will be taking baseline firmware from Blackwell, working with Tarun to get it updated, running it, debugging it. It's kind of a complicated thing that I think runs on a tester. So we try and get someone from Vanu Deshetti's team to provide like support on the tester with the chip. I think there might even be a DFT pattern involved. So I think Rupin in the past has helped provide that support. And so we can kind of do a kickoff with these people of kind of what we're doing and have the intern kind of start getting up, and maybe even we set one up beforehand to just give them like the heads up that it's coming, and it's time to do this for Ruben anyway, so it's good to get started. Yeah. 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 Mhm. Yeah, I think so. We had a chat where we were prioritizing them, and I think that was relatively further down on the priority list, mostly because I think the secure fusing was like POR required, had high impact, and I think there was concern that that one would essentially be they're going to put a lot of work into building a database, and then like they're going to find that just statistics protected us and we didn't. Like there'll be no fine, or we suspect there'll be no fine, because if things are going right, you know, there won't be a collision because of 2 to the 128th. Yeah. But we could create it. Yeah. Yeah. Or yeah. 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 I think Tarun is the new owner from Akanksha. There is, I think, I know there's at least a baseline from Blackwell. I don't know if they've like already started on a Ruben version of that, but we do have like a baseline code from Blackwell that exists that, you know, high level be the same. Obviously, registers move and addresses change and stuff like that. Um, and I think there might have been some very minor. I'm trying to remember if there are any minor changes. I don't recall any. But there is like a baseline code, and like I had mentioned before, essentially we got stuck on Blackwell not being able to iterate the code very quickly, and so we would, you know, ramp up like, you know, 6 or 7 people in a cross-functional meeting. We would see, oh, the thing is failing. We would spend an hour saying, oh, I think we should like get more detailed steps or try and get like a little bit more information. The firmware team would go off and it would take them a week or 2 to put the code together. Then it would take a week or 2 to get that sort of security approved for signing. And like a month later, we're like at the next step of the debug process. And so it was an incredibly painful, slow process because of the kind of like the security constraints around signing. Maybe also like there wasn't a ton of like support from the firmware team. Like Akanksha was responsive, but she was doing all kinds of other bring up stuff. And so there wasn't a whole lot of like full-time support there. So I think with Ruben, we're hoping that essentially, one, because we have debug keys, we kind of remove the requirement for security review, and hopefully Tarun will be able to provide us more support on the code side, but maybe also our intern might be able to help on the coding. I don't know about that. I mean, I think there's pluses and minuses in terms of like having someone here own it means that like once the intern leaves, we still have someone with knowledge of all that. Yeah. Yeah. Okay. Yeah. Yeah. And yeah, and the plus of that is it's much more isolated, right? It's not like you have to work cross-functionally among 5 teams. You just have to understand that you get the stream of certificate public keys and populate the database and search the database for collisions. So yeah, like I think if we want to give them an easy win, I think that's it should be relatively easy to achieve. The puzzle pieces. Yeah. What the error code means, yeah. TFT, yeah. Yeah, so for example, we could, yeah, like we could misprogram it. So we let's say we issue an identity key. We program the identity key in the part. We also issue a certificate to the part, and the part can reconstruct the certificate. It's possible that we program the key in wrong so that we sign a certificate for key A, but the chip thinks it's key B, and so like the certificate doesn't match the key that's issued. And so it's more like making sure that like the whole process works by taking the final keys and making sure that like all of the cross connections work. And we didn't fuse something backwards or sign something backwards or NDNS or whatever. Yeah. Mhm. FSP boot ROM. Did, did and then just also to mention Green Hills, which now is ISS or back to ISS, but they're the contractor that basically manages the HSMs, and so we gave them kind of a protocol. They implemented the HSM side of the protocol. I think it's all working as near as we can tell. I think it worked on Groot SR01. So we think that's pretty much done, but like it's always possible that something goes wrong. We don't put the right key in the HSM. We don't create the right certificate structure in the HSM. And so we would need to go back to them and say, hey, can you make a change? I think it's pretty baked in by now, but they would also be someone involved in the process. I think I kind of feel like driving and owning all this is too big. I think that might be a little bit on the small side, but also like details make things longer than we expect. Like, so we're going to have multiple products. Are we going to look across a single product? Are we going to look across all the products? Are we going to capture our own database? Are we going to go interface with the existing CFTT database? Are we going to go troll through the CFTT database to just check to make sure that we haven't like double entered keys already? Yeah. So uh, for the PQC database, how do you envision it working with that? No. Okay, but okay. So just to clarify, this is like only the collision search database, not the PQC database for delivery to factory. The what's the PQC part that it? So there is a database that exists. Okay, so okay, so that is owned by like the CFTT folks have that owned currently, and their plans to migrate it to like a special fancy database that's like performant and geographically dispersed and yeah. At least it's tagged to their team. We're giving them requirements for how to build it. It's also like a mission critical ops, like factory goes down if it breaks. So don't make an intern build it to be blunt. So they're different. They're two tasks. So there's one task of searching for collisions. No one's doing that. There is the task of so there's three tasks. I lied. So the second task is collecting all the certificates we issue for like slow traceability our records. CFTT database currently does that. There's a third task of taking that old slow record database and making it available in every factory 24/7 around the world without fail. And the CFTT team is going to work on migrating their database to support that capability. And so okay. 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 No, that makes sense. I just wanted I just wanted to make sure we were scoping it to the collision detection aspect of it and not the other parts of it. That's fine. Yeah. So we can okay. There is a slow database, but no one's searching it. It's basically like we have the record, manually. If like a customer comes to us and says, hey, I have this certificate with this product, we can go and look in the database and be like, oh yeah, that was made on this date. Or if a customer comes to us and says like, this is the PDI, the serial number of the part, we can go into that database and look up its public key and its certificate and pull it out. And we've done that a couple times for debug. And so we have a database for like debugability and having a record of what happened, but there isn't anything happening in that database with respect to, are there collisions? Like, is the one being added colliding with one that exists before? We just throw all the public keys in the database. And it's indexed by PDI, the serial number. And so it's possible that multiple chips with different serial numbers pick the same public key. And there's no check when we put it in the database to make sure that no one else is using the same public key. Yeah, I think, yeah, I think, okay. No, I think you're right, and I think there are definitely more failure modes, right? As we go to the secure fusing flow, like maybe the RNG gets stuck, and you're getting some like semi-random value out, but like after you look at 1,000 parts, you realize like 5% of the parts are always picking the same key because of some failure mode that we don't detect on the hardware, and so like having the database would, in a way, kind of be another check that like everything that's happening super secure on silicon is actually like really random and not like pseudo random or failing in some unknown way. Yeah. Yeah, so the way it works is all the HSMs, they use this thing called like Rabbit MQ, which is basically like a queuing system. And so all the HSMs will essentially put all the records into this queue, and the queue is connected to our centralized database. And every 10 minutes or every hour, the central database goes and like pulls some data off the queue and populates into the database. And like so kind of like the HSM is like streaming records into their local buffer and streaming that to the database. And the database is kind of slowly accumulating this data, but like the database doesn't have like to the second everything that's happening. It's not like it's kind of like eventually all the data ends up in a database, but the database isn't like a point of instantaneous coherence about everything that's happened in the HSMs. But yeah. Well, it may not need to be that strict. I think basically at the database, you'll have an order. You'll basically be adding these things in order. And so if you put this thing where you're adding the certificates in order to the database, you basically can, each one as it goes in, you check against the database. It's not there, it gets added in. You take the next one checks it. So like as long as you put them into like a single file line at the database, then you can check them and you'll have some, when the data gets to the database, you'll detect that there was a collision. It's possible, yeah. 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 And I think they can talk to the database team as well, because like I think like search, like one search per entry might also be like a really painful, like I don't know if we'll like snag the real production database, because it's optimized to take in lots of data and slowly query one thing at a time. But if if every entry also requires like a full database search, that might be tricky, especially if it's not, if the database isn't indexed for the public key. Like it might be easy to search for like a serial number because the database is indexed to the serial number. But if the database isn't indexed to the public key, it needs to walk through all the elements and find the public key. And so maybe we talk to the safety database about also indexing it by the public key so that it's easier to search and find if a public key is there or not. These might be interesting things for an intern to explore. Prototyping it. Yeah, yeah. Mhm. Okay. Let me. So the one complicating factor is the database lead. I think is on like family leave starting around now for 4 to 6 weeks. Maybe by the time the intern gets here, it won't be a problem. I'll go and look at the schedule. Oh, okay, okay. There he. Yeah. He's a manager, right? So there's a team, and I have the picks for the backups, but they might be a little. Yeah, yeah, yeah. And yeah, and I think collision detection is totally like greenfield. They don't have any, they don't, we haven't said that's a requirement. They haven't gone and at least to my understanding, invested in looking for collision. So I think I don't expect a concern there. I think if we talked about like the PQ part of like delivering it back to the factory, they have a lot of thoughts about that and how they're like going to merge it with another database and move from like Cosmo DB to not Cassandra DB. Like they've done a good bit of work on like how they want to set that up to meet the requirements for production. So I yeah, we don't want to like disturb that, but yeah, like finding collisions I think is like greenfield, and they usually Matt's really receptive to it. I can talk to his two picks that I've worked with before who I think are covering for him and make sure they're okay. But it will come in a little like uh, I don't know how the people covering will respond with their manager like out. Um, yeah, I'll try. I Monday the 25th. So they left already. They're back the 10th. And maybe he's usually like he's really responsive, and so like maybe he'll check his email. Maybe if I Slack him, like I don't know, I can try that and just be like, hey, is it okay if we do this? Yeah, yeah. I don't. They're yeah. So they're yeah. Yeah, I think they would be super open to finding a collision. I think if we said we have an intern to work on the PQ stuff, they'd be like, "What have we been talking with you about? Like, why are you throwing away all the stuff we've?" And then that's done lots of work, but they thought about it a lot. And so like I think that would be more stepping on toes. But I think finding a collision is like new, different, and I think they'd be really cool with that. And um, they might have some feedback on like how to structure that more efficiently. Um, yeah, yeah, okay. Yeah. 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 I'll give them a heads up. I think I, the manager is usually great to work with and usually very receptive. I don't know how his reports will feel that like we just showed up with him gone and like the day after he leaves. Oh, by the way, we'd like to dump this on you. So that's the only. But I think it'll be okay. Yeah. 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 Okay. And I noticed not reports to Apoorv. I think Apoorv might be familiar a little bit. So maybe I would actually go to his hire manager and just kind of give him a heads up as well. And that might be easy as well. Or maybe I'll start with the reports, and if they're uncomfortable, we can ask Apoorv. Yeah. Okay. Different. Okay, thanks. Bye-bye.